Hello, welcome back. This is Calculus by Dr. Oz. Today we have two functions provided to us, and we're going to find the MacLaurin series for each function. But we're going to be able to use the power series of known elementary functions. In part A, we have just x cosine x. And in that example, we're going to utilize the power series of cosine x to reproduce the power series or MacLaurin series of x cosine x. And in the second case, we have a piecewise function, and we're going to utilize the power series of the known elementary function arc sine x to derive the power series of arc sine x over x. Let me just show you what the table I'm talking about for the power series of elementary functions. Here we go. Yep, this is the power series for elementary functions. So we have all the functions listed here, all the known elementary functions listed here with their power series and interval of convergences. So we have 1 over x, 1 over 1 plus x, ln x, e to the x, sine and cosine x, and arc, tan arc sine, and 1 plus x to the power of n. So we're going to sort of like try to utilize this table, which you can have a copy of that in the textbook or the lecture notes. All right, let's get started. All right, let's start. We have, in part A, we have f of x equals x cosine x, and we're going to find the MacLaurin series for the given function. Well, there's a long way to go, but what we want to do here is to utilize the MacLaurin series of known functions, because cosine is a very known function, and I think it's in the list of power series for elementary functions because it's an elementary function, right? So we can go ahead and then check the cosine x here. Okay, let me just do that here. Okay, let me just make this bigger for you. Here we go. So we have cosine x sitting right here. Right, we have the power series representation of that, and that comes with the interval of convergence. Negative infinity and infinity. So what I'm going to do is I'm going to copy the n term down. It's minus 1 to the n, x to the n over 2 factorial back down here. So cosine x as the power series representation, the summation minus 1 to the n, x to the power of 2n divided by 2n factorial. And I want to make sure that I got the interval of convergency correct. So cosine is convergent, in fact, for all x. Okay, so I can go back and just write here that x is in between negative infinity and infinity. Okay, so all I'm going to do is just to use this power series to write down the power series of x cosine x. Here we go. So I'm going to multiply everything by x. So this becomes x to the power of 2n plus 1 over 2 factorial. And the interval of convergence is the same. So this takes care of part A. Okay, you can go and choose a long way to reproduce the power series of x cosine x by checking all the derivatives, maybe up to the order of 4, and evaluating them at 0, and just using the definition of MacLaurin series, you can just expand f into power series. But here is the detour, because cosine x is a known function, so we should utilize the power series of the known functions to produce the power series of other functions involving those elementary functions. Okay, and I think this proves part A. And for part B, please move on to the next video.